Hello everyone. Today we are going to build a complete machine learning project using a k-means clustering. Suppose a movie production company wants to categorize movie based on their performance. Instead of manually analyzing each movie, we will use machine learning to automatically identify similar groups, right? By the end of this project, we will discover blockbuster movies, average performing movies, and niche movies using a k-means clustering. The first step in every machine learning project is importing the required libraries. So my first library is import numpy. Okay, import uh, pandas as PD, and then my second library is numpy as np, and then import matplotlib, pyplot, and then my fourth library is import a cbond as SNS, right? Just cbond as SNS, right? Uh, there is no visual output here. We are simply importing the importing the libraries required for our project. Pandas help us working with data. NumPy performs to make calculations. Matplot and cbond helps create a visualizations, right? So now let's upload our data set. Now we are going to a file, then upload the data and just copy path, right? And write here df equals to pd dot square excel, right? And then this commas and then last df put week here now. Well, we just got the data, right? Before building a model, we must understand our data, right? So df equals to sorry df dot info. We got the information here, right? So now we plot the data. SNS dot clear plot data equals to df. Then we call. Okay. Now I'm using the pair plot function from a cbond. Pair plot is one of the most powerful EDA tools. It automatically creates relationship between all numerical columns in the dataset. Instead of creating a multiple charts individually, pair plot generates them all in a single command. So my next library is from a sklearn preprocessing. Import root min max scalar. The next library is sklearn cluster for k-means, right? Okay, there is no visual here. Minimum scalar is used for scaling and k-means is our clustering algorithms. So my next step is feature selection. Feature selection and capital X equals to df, and we select the data, right? And so just we here and then okay run, right? So we are selecting only numeric columns. K-means cannot directly work with the tags like a movie name. Therefore, we keep only the variables that helps measure a movie performance. Okay. My next step is scaling. how to scaling the data, right? Enter and scalar equals to a minimax scalar, okay, and then x scale app, and then smooth set, right? And we got this data. Now that all values are now between a 0 and 1. Before scaling, revenue was in 100, score was between a 0 and 100. The models could become biased towards a larger number. Scaling solves that problems, right? So my next step is algo method. Algo method in Mixia. Mixia equals to excludes for key in range. Okay, then column and model equals to k means, right? And clusters and the school clusters equals to k, and random state equals to 42, and then and numbers of finite equals to a 10, right? And then model dot fit school and scale, okay. Okay. Now, no output appears yet. Huh? We are storing inertia values. Inertia measures how compact the clusters are. Lower inertia means better clustering, right? So now my next step is elbow curve, right? It's a PLT dot figure and fixed size. Fixed size equals to just 0.805, right? And then PLT dot plot, make it, and then range is 1 by 11, you know. Okay, then inertia, and then a marker goes to O, O. Okay, then PLT dot X label, it's inertia of cluster, so number of cluster, right? The PLT dot Y label, Y label is what? Inertia, inertia, and PLT dot title, elbow curve, and shows, no, we have got this plot, right? You can see a band or a elbow in the graph. The elbow indicates the optimal numbers of cluster. In our case, the elbow appears around the 3, therefore we choose a case equals to 3. Now my next step is train. K means equals to K means capital, right? So n clusters, this is equals to 3, and scale, then we run it. Okay, so there is no output. The model is learning patterns from the data. It is trying to identify the groups of similar movies, right? So my next step is generate cluster. Okay. DF cluster equals to K means dot label underscore then df dot head df dot head then close it. Okay. Just now, machine learning has assigned a cluster numbers to every movie. Movies with similar characteristics are grouped together. Cluster numbers themselves have no meaning yet, and we will interpret them in the next step, right? So my next step is cluster distribution, cluster distribution, and df cluster dot value counts, and now we okay. You're just mistaken. And this one is a capital R, right? Okay. So, cluster 0 contains a 15 movies, cluster 1 contains a 9, and cluster 2 contains a 6 movies, right? So this shows the how the data set is distributed among the groups, right? My next one is a next step is scatter plot, right? PLT dot figure, PLT dot figure, and then fixed size equals to 10 by 6, and then show here. We are now defining the X in budget, define the worldwide, and Y is an audience pool. This is capital, right? And then okay, we have light. So now we use a palette. Why? Because the color all are lights, so we do not identify all these colors, right? So palette equals to a bright. We are using a palette bright, right? And s equals to 100, right? So now okay, we just spelling okay. Now we got the graph. So each color represent a cluster. Movies with the similar revenues and audience scores appears close together. The visualize help us verify that cluster has worked correctly, right? Okay, my next step is df dot group by uh, group by which one? Cluster. Okay, and then just copy here this one. Okay, and just copy it and then paste it, right? Just paste here. Okay, okay, just make this. Okay, and dot me, and then okay, we got this data, right? So this is the most important This is the most important output of the project. Now we understand that each cluster represents cluster 0, high budget, high revenue, high ratings. So blockbuster movies, cluster 1, medium budget and medium performance, average movies, cluster 2, low budgets and lower revenue. Niche movies, now the cluster numbers becomes a meaningful business segments, right? So this was the complete project, and thank you so much